All right, here's our video today. The Nazis, radio waves, and the ionosphere part 2. And part 1 is linked below if you want to watch the part 1 of this. We talked about the ionosphere, and guess what? The ionosphere is made of, sure I have my pen ready, ions, right? So ions in the atmosphere, for example, we have oxygen, O2. We also have nitrogen, N2. So what an ion is, the atom has either more electrons than protons, or vice versa. So if we have, let's say, O2 and you see a negative sign, that means it has more electrons than protons. And if you saw a positive sign, it has more protons. So that's what ions are, and they're in the ionosphere, which is a layer of the the thermosphere. And the solar winds from the sun, they come in and they knock electrons out of these gases. And they also cause the aurora borealis, which I'll talk about later in the video. All right, clear that out. So basically, this video is talking about how the German scientists, the Nazi scientists in World War II, they found a way of reflecting radio beams, radio waves, that is, electromagnetic radiation, the radio waves, which have the longest wavelength in electromagnetic radiation. And they bounced it off the ionosphere, and they were using these radio waves to target London, target cities in the United Kingdom. So they would pinpoint targets. They let these German bombers like the Junker find at night targets. Simple as that. And here's the Junker Ju-88, right? They also had the Messerschmitt. But again, at nighttime, it's very hard to bomb at night. But at night, doesn't matter if it's raining or cloudy, these bombers would use radio waves to pinpoint targets. And we'll talk about how they did that. And like the last video, we talked about the layers of our atmosphere. We're in the troposphere over here, but the ionosphere is way up there in the thermosphere. I'll use green. So here's where the ionosphere is. Of course, that didn't come out right. Maybe we'll use purple. Bring it out. There we go. So just very simple. We have a radio transmission coming up, bouncing off the ionosphere, and hitting a target somewhere on Earth. Of course, we missed the Earth over here, and of course, radio waves don't travel just in a straight line. Let me give you a picture of that. Here's a better picture. You see the radio waves are moving in waves, like if you threw a rock in water, it will create these waves. And this purple over here, if you see the purple line, that's called line of sight. And that's what they were using first. LOS, you might hear it as LOS, line of sight. It's just where the radio wave travels through the Earth, not through the atmosphere, but it's just traveling in a straight line somewhat. And the problem with line of sight is it's very limited to distance. Limited. Has a low range of distance and it fades out over time. So if you could actually target your radio waves to hit the ionosphere, then you could have it cover longer distances. So that's basically what they found out. And before we can cover that, we should talk about the Lorentz system. So this is how it really first started. So try to get that name out, get our pen going here. Lorentz system used LOS. Remember, that was line of sight. So at airports, pilots would come in. Let's say we have a plane here. It's the best plane you ever seen, right? Planes would come in to the runway at night in bad conditions. Let's make our runway here. Here's our runway. And if you couldn't see the lights because it was cloudy or rainy, you can use the Lorentz system line of sight. So here there would be a transmitter over here, and it would send out these waves, radio waves. And in the plane, here's our plane in case you didn't know, there would be a receiver. And here is our runway. And on the left of the pilot, they would have these dots, like in Morse code. You would hear a series of dots. If they heard a series of dots, then they knew they were too far to the left. And to their right, dashes. So if they heard the longer dashes, they would be too far to the right, dots too far to the left. And if they had that perfect tone, that means they were on site. So now the Germans looked at this and they said, well, is there a way we can take this Lorentz system and target England, which is a longer distance away? Now, when the English figured out that they had these blind landing receivers, because on the plane you would have a blind landing receiver, they didn't know how it was possible for them to use it for long distances. Of course, Marconi, he did use the ionosphere. In 1901, he did send the radio transmissions from Europe to America. So the Germans knew this was possible. And so that was the next step. And here's a better picture of the Lorentz system. You see the pilot's hearing the dots. Over here, he's hearing dots, so he's going to calibrate himself. And over here, he's hearing dashes, longer dashes. And then he finally calibrates himself and he lands. All right, and here we have a picture of France. So the Germans already occupied France. So they set up receivers. One receiver, they send up a transmitter in Cherbourg over here, and then in Calais. And so if they wanted to target England, London, let's say, they would send a straight line in, targeting London, another straight line. Tempting to make my straight lines here. And where they crossed, the pilots would know this is where you would drop the bomb. Now, this isn't line of sight. They're actually, I'll use green, they're actually targeting the ionosphere and they're coming in like that. And the same was happening in Cherbourg. They're hearing this. They also have a receiver in their plane that's picking up so they can go straight. So a lot of planes would take off. The Junkers would take off from Cherbourg, and they would have a receiver that kept them in a straight line. And then at Calais, where they would have a second, get our pen going here, a second line would come in. When they started hearing the different radio frequency here, they knew they were over London or wherever their target was. That's how basically it worked. So again, line of sight wouldn't work because it's limited to distance. So they had to use the ionosphere. That's how the ionosphere was used to bomb England. And of course, the Germans would improve the system because the English would find out about this and they would jam the receivers. And every time the Germans improved it, the English countered. So there was a battle of the beams going on here, and that's what they would call this, the Battle of the Beams. But in the end, though, England was bombed, heavy bombing of England, and it almost caused them to lose the war. But that's another story. Now, a lot of English scientists didn't think it was possible for them to use this radio signals because of line of sight. They thought they were using line of sight in their bombers. But then when they found a bomber that did crash, they did find a blind landing receiver. They also noticed that they were able to find a beam near Spalding, which is what you see there, the city of Spalding. And then they found another beam. So there was a beam coming in from Spalding going out, and there was a beam coming in. The second beam was coming in to Derby. So we'll say that's Derby. Derby is just south of it, and Spalding over here, Spalding. And so they were able to. And by the way, Derby had the Rolls-Royce factory. Rolls-Royce factory, which is, I mean, you know about them, they're luxury cars, but they're also very important for making planes, fighter jets for the English. And so once they knew that the Germans were doing this, they had a code name to break it apart. So the code name that the British used to break apart this German navigation system with radio waves was called Headache. That was the code name. And the code name for the answer of how they were going to defeat this, how they were going to jam these radio waves, guess what it was called? Aspirin. Right? Today it would be called Advil, because most people use more Advil than aspirin, right? So again, just to sum this up, the Germans are going to use radio waves to bounce off the ionosphere. They're going to use 2 waves, and later they'll use 3 or 4 more waves. They're going to improve their system, and they're going to use those radio waves for pilots to target cities in England at night. And so I was just making a simple video on this. The last thing I talked about earlier is the aurora borealis. So when solar winds, get our pen going here, solar radiation, we'll say these solar winds hit the ionosphere, solar winds, they're going to knock into the gases like O2 and N2 and other gases we have like argon. We even have hydrogen out there, hydrogen and helium. Put that U in there. So when the solar winds hit these gases, they're going to knock out electrons. They're going to create, because every time you knock out electrons, every time you agitate atoms, you'll create colors. So when the solar winds hit oxygen, put it over here, when they hit oxygen, depends how high up in the atmosphere. Higher up in the atmosphere, you can get a red color. And lower in the atmosphere, lower in the ionosphere, when they hit, you can get more of a golden color, more of a yellow color, or even a green color. So you see this green is because of the solar winds hitting oxygen. If you're hitting hydrogen or helium, there's the symbols for that, you can get a blue color. If you're hitting nitrogen, it's N2 by the way. If you're hitting nitrogen, you can also get a red color, depending on where it is. And then you can get a mix of colors. So you get all these colors based on how the solar winds are hitting certain gases. Now, you only usually see these in high up in the north, and the reason for that is because of the magnetic field of the Earth. So when this happens, when you see these colors, it's interfering with the magnetic poles, and the magnetic field will target them, will kind of push them to the poles, our magnetic north and our magnetic south poles. So that's why we see these colors, and that's why we see them up north or way down south. All right, that's part 2 of our video.